Hello everyone and welcome to another episode of No Orientation Programming. I'm Joe and today we will create some debugging tools for our gaming server. At first we will make an wiki entry. Let's see, what's our week number today? 30. 30. Oh, okay. Logs 30. TGS debugging tools. Just debugging. Okay. TGS debugging. I hope this is create or okay or something. Let launcher. Nope. I think this is it. Dot links list, and then we have the man page of core. So we can save this. We don't need this anymore. Man core core 5. Okay, that's fine too. Medium.com. So what do we want? We want the version and date. We want to have the core dump. We want to have the process tree. Address. Several information, some information, general information. Then the core dump, the process tree. Okay, so we will make a little tool. Yes, we want to have the last log lines. And for the last log lines, we will Linux hint. Okay, first of all, let's make a terminal and check what this file is about. How to enable, yes. Ulimit age for okay, and the soft limit is 0. Perfect. Disable soft unlimited. We want to make sudo we will check the content of this file. It is a security limits.conf. Okay. Seems to be. Okay, here is an example. For everyone, soft core value. Soft core unlimited. That's fine. Do we need something else? Core dump enable permanent entity security whatever security Yes, we want to add this line softcore unlimited to this file. Perfect. To enable it temporarily, we should I don't know if this is possible with the normal user. Let's try. The current value the soft limit of the core is this, and now let's say unlimited. Okay, seems to be fine. Okay, then we want to, very important, pattern can be changed in this file. So when a program crashes, then, and if you have enabled the core dumps, then sometimes you see for a segfault or something similar, the message core dumped. If the core dump is enabled in Linux with this command, then we have a core dump, otherwise it's just an empty message. So with this we can pattern, yes, permanent in file syscontrol.conf we can change the core pattern. And what do we want? By adding following line in, okay. I like the approach to have the core dumps in its own directory, but that's strange. This should be fine too. We have su keep. I want to have the date here and then the core and then the application. What is E? process or thread's COM value, which typically is the same as the executable file name without path prefix and truncated to a maximum of 15 characters, but they may have been modified to be something different. See the discussion of book PID COM, common name. Okay, let's try PID of TGS, and then let's say proc 621189. What is the COM value? Ooh, what? Okay, that's unexpected. It may be, yes. Okay, that's interesting. It seems to be uh-huh. Let's see. PS EF. Hi Nick. How are you? TGS. Oh no, grep. Okay, let's see what we get. Today we will make some debugging tools for our server. I want to be able to get core dump, and I want to have the last log lines of the process. If our server crashes, then I want to have the last log lines. And theoretically there should be a tool for that in Linux. But I don't think the tail is the right one. So we will make our own tool. Git clone. So this is a good practice. The process of thread's COM value, which typically is the same as the executable file name. Okay, path name of executable with slash is replaced by exclamation marks. Not cool. Path name, not numeric. Host name, same as node name. TID thread that triggered the core dump. Thread ID of thread that triggered the core dump as seen in the initial PID namespace. Okay, number of signal causing dump. Time of dump. Numerical real UID of dumped process. Yes, I don't know. Okay, let's keep E. Core of E, and then the time should be in front. %T. Okay. Then what is S? Number of signal. Yes. Core. Yes. That's the signal. That's fine. U. numeric UID of dumped process. I don't need this, I think. Numeric, no, GID, group ID, and the PID, that's PID of dumped process. I don't think that's necessary. Okay, so we have the time core of the application and the signal that caused the dump. I think that's enough information, hopefully. Okay, so the same should be used here. Let's see what we get if... Let's change this. No. Let's try to temporarily set this. Permission denied. Oh, come on. Kernel pattern. Okay. So then I try to change this in the file as well. Etc sys control conf. Okay. So we take this, copy, and then okay. So now we should have a dump in the subdirectory core dumps, the time, and this name. Okay, so I have prepared something, and that is a command. We can make a command, or we can execute. In the administrator section, we have the debugging, and now we can execute some failure. For example, illegal instruction. Illegal instruction? No, that's interesting. Here we don't have a core dump. That's strange. We should get an core dump for a segmentation fault. Okay, that's strange. I have tested some connections. That is, at the moment, we have we had a little problem last time. That is, if we started 10 connections, then we only had 8. I don't know if you can remember. And now we can make some more connections. So now the server has 4,000 connections, and the cycle time is 9 milliseconds. That's quite a lot, but at the moment for us it's good enough. We will improve this later, but for now I think it's okay, because nobody is at the server right now, and we can improve it by later on, because we can make a special scheduler for the connections. That means at the moment we have a cycle time which is looks like that. we have the cycle time. And this time takes, this cycle time is at the moment 9 milliseconds. Why? Because we have one process, a group of processes like the dispatching, TCP listening, and so on. That's the general process list, and then we have all the connections, the gamer interacting connections processes. For each connection we have a gamer interacting process, at the moment 4000, and this is the second group. And because we have, the group is so big here, the cycle time is consists of the first group A, and then a lot of connection processes, and then again A, B, 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 and then A, B, 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 B. And so this is kind of bad because, or it can be improved, because this is the general scheduler, and the general scheduler is made for general purpose stuff. So in any application, it's in most applications, the general scheduler, which is defined in the main here, just making 16 bursts and then sleeps 2 seconds. So this is for general purpose stuff. For most cases it's good enough, but in this case it's special, because we have a lot processes of the same type, like in this case, and it would be better to do something like this, grouping the B's into a special scheduler, making something like this. B1, B1, A, B2, B2, A, B3, B3, A, B4, B4, and then again A, B1, A, B2, B2. So a better approach would be, and then we have, for example, 2 milliseconds, or even 1 or something like that. So we could split our group of processes. It doesn't matter if for this group it doesn't it takes 9 milliseconds plus 9 milliseconds plus 9 milliseconds. That's just the time it takes for the last B last. It would take 3 times 9 milliseconds to get, no, that's wrong. The last B is here. The last B is here. At this point, and it takes 9 milliseconds for the last B to get information. It doesn't matter if, in this case, this is the last B process, the last connection process, and it doesn't matter if we insert some the general purpose processes in between, because it's just a little stretching of the cycle, the delay for the last connection, but we would be way more responsive in all the other cases. So in this case we just need a different scheduler. So it's all about scheduling. So you have one group, one general process group, and then a lot of connection processes. And because the general purpose scheduler, like in the main, is always just calculating the whole tree, and the whole tree is this general purpose process and this one, and then we have a lot of connection processes, and we don't want to wait for all the connection processes to be finished, and then so we are stuffing these processes in between. This would be one solution, one improvement. Then the other improvement would be to make a thread pool and have B1, B1, and here B2, B2, and then here we have B3, B3, and here B4 and B4, for example. And then again B1, B1, B2, B2, and so on. So this would be another improvement. Like this, we could decrease the cycle time even further. So we have in the future of this project, we will have still stuff we can improve. We have a strategy for that, but at the moment it doesn't make sense, because if you connect, at the moment we have 4,000 connections going on, and 10 milliseconds for all the stuff calculating. As you can see, you almost you hardly notice that there is something, that there is a lot of going on at the moment. You can play very well. It's still fine to play. So, and as long as this is the case, so it's responding perfectly, even though we have 4,000 connections, and only if there are 4,000 active people, then I will think about improving that. There is always, we could say, yes, let's improve it to 50,000, because you could say that this is not scaling. Let's try to stop these connections, and let's make 10,000. I did not try that before. Okay, so now we have 24 milliseconds cycle time. As you can see, now the connection was a little bit slower, but still the frames are reacting very fast. It's still quite responsive, but I feel the delay now. I think now it's 20 milliseconds seems to be. Yes, I can feel the 20 milliseconds. So it's not scaling in the sense that you always have a bottleneck somewhere, and only if we reach the bottleneck, then we should do something about it, I think. Yes, so that's but for me it's good enough. It's fine. The target was 2,000 connections. And that's perfectly fine. That was the target, for the first target. Of course, in the future we want to have 50,000 or more, 100,000, but at the moment it's fine. So but so I'm quite happy. I'm quite happy with the result, because I thought that it is even, I thought it is worse than that. I thought that we have 100 milliseconds with 2000 connections, but I was surprised that it's with 4000 connections, it's only 4 milliseconds. I mean, 10 milliseconds is a lot. It's huge. It's very slow in that sense, but as I said, I think it's good enough. The only thing is, now we should try what is happening if we decrease this number. This number is telling us how fast the connections are sending. One moment. Yes. So, if we have if we create connections, for example, let's for one moment, just let's create one connection. Then we see this connection, and this connection makes a request every 1 second, and it's requesting a new frame. It's refreshing the server list. So the connection processes in the testing application. This is the testing application. We have started the testing application in interactive mode, and because we have interactive mode, we have a command interface, and in this command interface we can create the connection, the number of connections, and the interval, how often they each connection is sending the R command for refresh, and the server is responding with the server list frame. And we have tested 4000 connections, that's fine, but what if these 4000 connections are sending a lot of data? So let's see what is happening if we make 4000 connections and making double the load. What? Okay. Okay, yeah, I stopped the connections. So the cycle time is not changed, because we create a frame for every connection. Every single connection we create the frame. So this should be, so we see a lot of packets here. A lot of packets. Thousands of packets. Every second, 4000 packets. 8000. The response, the request and the response. So let's make it even. So with S we can stop all the connections, and then we can recreate the connections and say, for example, 300. So the interactive testing process is ramping up the connections, bursting the connections, creating 10 connections every 10 milliseconds. So we have a more or less realistic scenario. As you can see, now we have 1 millisecond or more. If 4000 connections create a request every 200 millisecond, let's make 100. Yeah, that 2 or 3 milliseconds more. Interesting. So there is space for improvement, definitely. But it's not annoying. It's not annoying. I think you told me last time what is the the fastest key typing, the fastest speed for key typing. I think it was 400 per minute. I think 400 per minute. Yes, I think 6 per seconds. 1000 milliseconds, 6. So that's quite, yes, that's quite fine for me, I think. Let's check this. I can see it in the trace. Let's create the game. We should see this. Yes, we see the frame. Now we have a server for this frame, and make test and then enter. So we have a lot of this is the time counter you see, and then and this should be H and L all the time. Or left and right, yes. Yes, that's left and that's right. So the time in between is 100 milliseconds. Yes, I think that's good enough. So 4000 connections, 100 milliseconds. The first stage is that's good. Okay, so that's a good result. Okay, let's write that down. Speed test. First speed test. Debugging, we have on week 30 TGS speed test 1. Performance test 1. Okay. Then the core dump. Yes, why don't we get a core dump? That's strange. That is strange. Terminal. ulimit softcore C. Why? Unlimited. Let's connect again. No. Debugging, segfault, segmentation fault. Maybe the pattern is not good. Maybe I think we should have not removed this, I guess. That was bad. I think core dumped. Why don't I get a core dump? when it was deactivated, we were able to see the message segmentation fault and then core dumped. But now we have enabled the core dump and we don't see it anymore. Okay. Can I read this value? Kernel is equal to illegal instruction. Debugging segfault. Strange. Unlimited. Okay, whatever. Report. Max keystrokes per minute. 400 keys per min. That means 6.6 keystrokes per second. This means 1 keystroke per approximately 1 keystroke per 100 milliseconds. Tested 4000 4K connections, 100 milliseconds. Result is a cycle time of approximately 13 milliseconds. Bad but good enough. Okay. That's okay. So now I want to see the core dump, and then I want to register a signal handler. If we get one, what do I want? If the server crashes on the server, I want to have some information that I can use to debug the stuff. For example, I want to have some general information, address of the bad command, then the server version, the date, the core dump file, the process tree. I want to see the entire tree structure at the moment the server crashed, and I want to have the last log lines. For the last log lines, we will make a small and simple tool, and yeah, I think that's okay. That's enough information. I can't think about what we should save other than that. I think for the first run it's good enough. Okay. Performance test done. Okay. Debugging. maybe I have to reboot. So the core dump, we could activate the core dump on the server. Yes, we can activate the core dump on the server. Let's see. Keybus, okay. Then we have serve ext. So serve ext. Come on, ext root. Yes, perfect. Then we add in file limits. We say for everyone the soft limit for the core dump is unlimited. And then vim of syscontrol conf has this pattern. Oh no, I think we should be able to remove the slash. I think that's okay. So, and then let's make a reboot -f. Okay. Yes, so let's make the tool. Examples. Example 1. Example 1. How should we call this tool? How should we call this tool? A tool that is saving the last log lines as soon as the standard input is closed. I don't know. Log catching. Bad name, but good enough. Testing. So we need a Mason build file. We need a main build, a main file. Then we need CPP processing, log catch supervising. Processing LC supervising. Okay. And then we have another CPP processing log catching. Okay. So we need a Mason file, which is do I have git attributes? We don't even have okay. We don't even have the submodules initialized in this repository. Okay. Git submodules. We can add git submodule add yes. Git submodule add no orientation programming and then processing core.git. Yes. And here we have processing common.git. Fine. Okay, we have the core and we have, yeah, the common and core. That's cool. So now git add submodules, add processing submodules. Cool. So now we have in the Mason file, we have the sources of the core. Let's see. The project is log catching, executable file log catching, dependencies, CPP arguments. We have the core. The core consists of processing, log, listening, transferring, debugging, and commanding. That's the same, that's fine. Sources common. Res, libtime. For this project we don't need res. The other ones are fine. We don't need any one of these. The source specific we need, yes. LC supervising, and then we need a log catching, CPP, sources specific, core common, includes core and common, yes. So from top to bottom, project fine, import core common, specific, sources, get compiler, why do I need this? I don't need this. Yes, let's keep it. Mason source root. Inks. To TCP convert, we don't need this. Custom target, we don't need this. Res paths message, no resources. Dependencies, threads, okay. No, we don't need threads. No JSON CPP tclip, no crypto, no curl. Run command ls resources, we don't need this. We don't have resources. The CPP arguments, application name, log catching. This is wrong in the testing tool. Fix typo in Mason build. Okay. Okay, perfect. Now log catching, project name, have stream, have s stream. Do we need this? Maybe. Have log, yes. Show address, no. Info buffer, disable tree default 1. Yes. Okay, CPP arguments, warnings. That's fine. Then we should be able to compile this thing. Not yet, because we have log catching supervising. We can keep this. Okay, tclap, debug, verbosity, licenses. Yes, if get licenses print, and tclap, application close request, and let's see what the compiler tells us. We don't have. No, this is fine. Okay, let's see. Mason setup build native. build native Ninja resource, no such file. Oof. What is terminated? What is terminated? Today we want to terminate things. We even added some commands so we can terminate our server intentionally. So we can make illegal instruction. The compiling process ends terminated. Unexpected. Compilation terminated. Yeah. No, it's yes, it's terminated because I'm doing bullshit. So I have to fix this. But at the moment I don't know how I should fix it. Yeah, the fault is not in the compiler. The compiler is just telling me in a polite way that the problem lies between the chair and the keyboard. Special code needs special compiler, yes. Okay, I told the compiler that the standard library includes the resource file, and the resource file header is including resources.h, and this we could. Okay, that's interesting, but I will do some nasty stuff. I will do some nasty stuff. That is TGS build native. Here we have the resources h. That's an auto-generated tool. And we just make an empty header file, and then we should be able to compile this thing. Resource does not name a type. Okay, then it's not empty. Then it's not empty. Okay, env, that's fine too. We need this file. Okay. Okay, at least compiling but not linking. Crypto. Oh my god. Yes. Okay, now yes. Poor. Hui. The standard library is dependent on crypto stuff. We have a lot of cryptographical stuff like SHA 256 and stuff like that. and I don't have a define. So I have a library. And this library should be split into pieces. If you have a library that is dependent on some other stuff, we should split the library. Okay, we will split the library, but at first we will make some nasty stuff. Really nasty. But I don't care, because I just want to make the tests. So we make something very stupid and add the dependency of the crypto stuff. And then we add the dependency of JSON CPP, and then we can add the threads too. No, we even need curl. Oh, that's so stupid. So I need the entire dependencies in this library. Okay. So undefined reference to resource find. Okay. Yes. We need the resource find function is, yes, we need this. Oh, so we don't have a clean structure for the library. Yeah, it's too tightly coupled. It's bad. It's too tightly coupled. Okay. Undefined reference to P resources and. I have deleted too much. Resources and. Resource, yes, we need. Okay, that's one of the next tasks I have to do, because now it's the compiler removed this because the point is 0, I guess. Okay, I have a const char of pointer of this. I hope this is good enough. And then the length is 0. Can we use this? No, that's not the problem. That wasn't the problem, but we have to compile this thing. Oh, we have to compile this thing. Oh, God. Oh, that's nasty. Okay. Resources. 0 array, yeah, perfect. Now undo. Let's make a dummy thing. So now it's linking and it's fine. Okay, that's very bad. But good to see. Yes. The supervising file should testing supervising should just start the debugger. So this is the function initialize. Initialize, and this yes, TGS testing is log catching, and here we have to include log catching.h. So the supervising process is executing initialize, starting the debugger on port whatever 3030, and then we start the application, and the supervising process should just return children success. And it doesn't have any state, so we don't need a process info function, essentially just the initialize function. We don't have a state in the timeout. We don't have this and this. So for the supervising process, this is enough. Okay, and then we need the success initialize. Okay, let's make a ninja. Not declared. Ooh, yes, because we need system debugging. Okay, it's compiling, that's fine. And then next thing, this is our application. So now this is our application, and this application will be reading the input, and if the input is finished, then it's creating a file. So yeah. I will get the beer for one more. So that sound. So okay. How is the server doing? Oh, we can still connecting. That sounds fine. Root. Fine. So TGS deployment. Deploy. So now the first one, kill. No such process, that makes sense. 2, replace. 3, allow. 4, start. Now let's say kill. So how are we starting this thing? Yes, on TGS, and then yes, we want to make that's one big to do. We will make debugging, we will make information general, and then report content of the report, and then how is preparation? Prepare. Is this correct? Preparation. TGS service file. We need to create a Linux service file for the server finally, and then we can restart and enable the service. So here that's fine. Okay. We have enabled the core stuff. Good. So we want to start the server. What is the server doing? We don't know. We should increase the verbosity to 4, and then now I want to check. Yes, I have to connect. If I use telnet Naigulus USTO, then I am connected as a guest, and in the homepage I only have access to this area, but I want to execute an illegal instruction, so I have to connect to the server, and then localhost connect to the server with telnet, and then I'm administrator, and then I have access to this page and debugging, and then let's try to make a floating point exception. Floating point exception, okay. So I am able to crash the server intentionally. But as it seems, we don't have a core dump file here either. So something is wrong with the configuration. O limit SC. Why is it 0? It's so strange. Unlimited. Connecting illegal instruction. No core file. I'm missing something. I don't know what it is. Okay, whatever. Let's continue the application. The log catching application. For one moment, step by step. First, we will make create the logging stuff. Yes. Okay. Debugging preparation. Content report core dump. Fine. A log catching application should be able to save only n lines in memory, save log content to file as soon as standard in closed, and then implement signal user 1. So if we send a signal to this application, then the current implement signal user 1 save log content to file if requested. So there are two events in which the log catching application is dumping the log. Hi Lucas, how are you doing? And here we want to save, yes, file name is somehow date and then log and then number. Yes, dot log. So this will be the task for this application. Yes, quite fine actually, because we have made the first performance test for our gaming server, and we tested 4,000 connections, and every connection is sending a request to the server every 100 milliseconds, and we have a cycle time of around 13 milliseconds, which is quite bad and slow, but it's good enough for our first version of the server. So actually that's quite cool, because we can improve the server later on. So it's a cool example to show how we can improve things and remove bottlenecks, because in my opinion, scaling means to remove the bottlenecks, and we should only remove bottlenecks as soon as we hit the bottleneck. So at 4,000 connections are quite okay for now, and the active users at the time being are 0 users, so we should get at least 10 users to think about that. So it's okay for the time being. And for the server, we want to create some tools and mechanisms to be able to debug the application in case it is crashing because of some bad event. And we want to save the core dump and the process tree, the complete state of the application, the log lines, and some other stuff. And for the log lines, we are creating a small application called log catching, and this application should save n lines in memory. So we have a list that is member variables, std list of std strings, m list, m lines, whatever. And we should include string, I think. Yeah, hopefully this is fine. This is a list, so we can start this thing, and then we want to, yes, we start. This is initializing or temp. vi tools. I want to cpp processing. I want to change the template file. This is annoying. I want to have at least 3 states here. That is start, main, and temp. Main, okay. So, and then I want to read the standard input line by line. For the log catching tool, I want to have an integer. So, auto test. We don't have auto test because that's not a testing application. We have an argument. Number lines. Num lines. Yes. The short option is n. We say number of lines. Number of lines to be saved at the end. To be saved. Okay, this is no switch argument. We need a value argument. Oh yeah. So this means n number lines it's not necessary, so this is not required. False. It's an optional argument. It's a value of integer, and the default number of lines is 100, whatever. Oh yes, 100, it's good enough. So we have number of lines and we have an output file. Should we yes, value arg string string. I hope this is fine. Output file. Let's see, in the server we should have a string option here. Ah, damn it. No, we don't have. Ooh, yes. Out file. Default is log, and out file, name of the output file. Okay, argument out file. Where was the args? Out file is equal to argument out file get value. Should be string, I think. This should be a string. Let's try to compile this thing. Oh, it compiled. Strange. Okay. Log catching help. We have an out file string, name of the output file, and number lines N O N V D. Okay. Okay. So somehow this seems to be working. Okay, start. We want to read a line of standard input. We have this in the main. Okay, yeah, perfect. So the next is seek action signal. Seek action. Literature. We save these to entries. Man page signal 7, and then man signal seek action 2. Perfect. So then we can concentrate to this thing. C read standard in line. C++. Reading from standard in C++. Get line. Man get line. No. C++ get line. That's a different get line. Yes, exactly. This is what I'm looking for. The delimiter. Oh, cool. We have a delimiter. The default delimiter is new line, I think. Extracts characters from input stream and stores them in string until the delimitation character is found, or the new line character for 2. Yes, that's good enough. So let's check something. I want to set the standard input to non-blocking. I want to set the standard input to non-blocking. This is done with the common file non-blocking set, yes. STD in. No, not STD in, that's wrong. Standard in file, yes, file number it's called. The first one is is a file pointer, yes, and the other one is the file number. And I guess this is what we need. Yes, the integer of the file descriptor. So this should be compiling, hopefully. Was not declared. We should be able to. File executing. So we have in the file executing, we should have the correct include. I think it's file control. No, it's not file control. In which header is this defined? Oh, come on, header. stdio. Makes sense. More or less. stdio.h. Nope. Unistandard. Yes, of course. Let's remove it again because we don't have included the library, the lib, the SPC. Okay, now we can check what we need. Yes, it was Unix standard. Perfect. Perfect. So now we have non-blocking standard input, and then we go to state is equal to state main, and here we check the return, yes, of get line return value. A call to this function may set any of the internal states of ES if. Additionally, in any of these cases, if the appropriate flag has been set with ES and the function exceptions and exception of type is thrown. Ooh. Yes. Let's try this. I want to do it like that. Okay. Get line. Get line of C in. C in. This is interesting. Can we have C in? Yes, C in, and is the IO stream that represents standard input stream. Does this thing have a file number? This would be interesting. Nope. Okay. cin, and we want to have one line. And we should get string line. We should get an was not declared. Yes, include I think IO stream. Yes, IO stream. IO stream. We include IO stream, then we have standard input, yes. And if we execute this thing, okay, it started, it's fine. Let's see in which state we are. We should make it easier for us. Proc. I want to see disable tree default 0. I want to see every process immediately. File executing. This means ninja and log catching verbosity 4. Yeah, perfect. And here we have nc localhost 3030. So this is the process tree of our testing application. We are in the state main. That's fine. And I want to see if line is equal to whatever. Proc inf log line c string. We should see this line cyclically. Yes. Perfect. Perfect. And now we say echo test. And then new line. And then test 2. Let's make a printf of test 1 and then test 2. And then another new line. So now we have 2 new lines. And this I want to see in the log catching. What is happening if we... Oh, here, let's see. Yep. Oh, perfect. Here we see the 2 lines, test 1 and test 2. We are printing 2 lines, test 1 and test 2, and the log catching application is printing out these 2 lines, and at this point we should get an error. We don't get an exception. Get line. So EOF bit should be set. Of the stream. Okay, that means if not cin UF end of file. We say if line.size, and only in this case we print a line. Yes. And if not EOF break, otherwise return positive. And this should be quite okay. Oh, perfect. Log catching returned successfully. We have printed out only 2 lines. That's cool. One strange thing is that this... Oh, yes. The supervising process of the server, what is... Ah, come on. Is returning children success. Yes, that makes sense. For the server it makes sense. But not for the log catching. Not for the log catching. Okay, so the supervising process is should return. We have a member. We have a member variable called a processing pointer MP application, and the application is MP application. We have to initialize this variable MP app. We initialize the application. We are starting and creating the application. If not application, then could not create process. And we are returning MP app success. And now the application should shut down as soon as the lines are printed. Perfect. So we have our supervising process, which is now checking for only this process, not for all the children, because in this case we return pending because one child is still in pending state. So only if all children are in the positive state, then we can return positive. But as long as at least one child is pending, then we return pending. And now we have changed it to in such a way that we return positive if this application core is returning positive. So that's fine. It's cool. Looks fine to me. And here we have to do save log. If not line size, then break, otherwise do something. Yes, that's it. We try to get the line. If the line is 0, then we do nothing. If we got the line, then we print something. Yes, that's perfect. Here we say mlines.pushback line, and if mlines.size is bigger than num max lines we initialized this thing is equal to environment of as unsigned integer. This was I think num lines. Yeah, whatever. Num lines. I think it was num lines in main, yes. So we saved the argument in num lines, and in the default case it's 100. And if our list has more entries than we want to save, then we say pop front. So we have push back and pop front. Removes the first element in the list container effectively reducing its size by 1, but only if we are too big. If we, yes. Okay. And then so that's cool. If end of file, then we save the log. And for this we have void log save, whatever. Yep, log save. Okay, that's cool. Then we have a string I opened the same file twice. Out file, I want to call it not out file, that's not cool. Argument name base, and we call it sp, and then name base name of the output file, and this is log string. Yes, perfect. And that's not out file but name base. Cool. This means we have the name base is equal to environment name base as string. So, and now I want to get the date. So we have a date buffer. C strf time. I make a mixture of C and C++. I know that's that's really bad, but I don't care. C++ reference C++. Yes, I want this one. Yes, that's fine. Oh, perfect. Look at that. Time, raw time, and then yes, put buffer strif time. Yeah, this just copy this stuff. We have time age. Okay. Oop. 80, boah, 80 is too much, I think. But whatever. Time. Info time. Time. Time raw, yeah, whatever. Time raw. Local time is info time. We want to have buff, size of buff, and then the info time, and here we have log catching, file name, data, base name, and number. So we have the number. Let's index file is 0. We save the whole stuff in here. Yes. Oof. String prefix file. Yeah, okay. So here we have the date. Proc warning log saving to file. Prefix file. Name file. C string. Okay, we have time raw. Buffer, this will be the prefix and the base. So this is the prefix. And then we have the number. And I want this thing to be the year in 2 digits. So small. Then directly after that, I want the month. It's M, small m, month as decimal. M, and then I want the day of the month, 0 padded. Oh, that's a good one. Small d. And then an underscore, I think. No, dash. Oh, can I use? No, I can't use the other stuff. Okay, no, so but let's no, let's make it like that. Let's do it like that. We have 2, 4, 6, 7. Let's make this thing 16, 10, and then we make a string prefix prefix file is equal to string of the buffer plus name base plus underscore, and then the name of the file is equal to prefix file plus toString of index file. No, that's not cool. That's not cool. S printf s n printf of buffer size of buffer s no u okay. We have a base name. We get the current time, the info of the local time. So we get the current time, and then we get the local time structure of the current time. Then we make a formatted string. Then we make a string here, string of the buffer, and then the name base, and then underscore, and then we print the index in this format, and then the name of the file is the prefix, and this here we will have a while to do while because we will be searching for the file name. Do I need any lib file sys? Can we compile this thing? Enforce not declared more introductions. Hi. We are coding like Lucky Luke. So, perfect. Okay, that's strange. I did not expect this. Test 1 and 2. Main. If not EOF break, but it is breaked. That's interesting. Saving to file. Okay. The application is still running. Why? Productions, did you ask me last time for the interprocess communication? Was this your question? Last time the internet connection broke up, and I finished the testing of the server, and we achieved quite a lot of connections. We made 4 connections, 4K connections, 4,000 connections, and every connection is sending a request to the server every 100 milliseconds, and we got 13 milliseconds of cycle time, which is kind of bad but good enough for the first version of the server. So I'm quite satisfied, and we later on we can improve this thing, so it's quite good actually. And now we are preparing the debugging of the server. If the server crashed on the host, on the remote host, if the gaming server crashed, then I want to have some information about the crash, like general information and the core dump, the process tree, the last seen process tree, and the last log lines. And for the last log lines, we are making a small application. And this should work, because in this case, this was working, I think. Yes. No, we have to. Yes, I understand. If EOF, then return positive. And if not line size, yes, then okay, back. Die Frage kam, glaube ich, nicht von mir, aber danke fürs Abholen. You're welcome. So essentially the question regarding the inter-process communication is this process structure is not defining or requesting any inter-process communication. We have in every application we have a lot of processes, but the inter-process communication is not defined. That means we only have a rough structure predefined, but how you send the data between the applications is how you like it. Tools, changing the CPP processing a template again. I want to have, come on, one more tab here. Okay. So you can choose whatever inter-process communication you want, everything that is possible. For example, just a member variable. If in the easiest case, you start a process like here. If you start a process, it's always the same. No matter where you are in the system, it's always the same. You create the process, then you configure the process, and then you start the process. That these three steps are always the same. And when a process is started, then it's running in the background. This means this thing gets calculation time unconditionally every time it's running. That means every process gets a short amount of CPU time in every cycle. So we can be sure that every process has a progress and is doing something. And as soon as we have started the process, we can just go on with our stuff. We don't care about that anymore. Only at a certain point we want to check is this, if we are done with the stuff on this level, then we can check if our child has some result for us. Then we can check what is your success. Is this child finished or not? And if yes, in the most simple case, we just have a member variable here, for example. This is the case for the HTTP requesting process. If we want to get a website, then we start an HTTP requesting process, and we say we want this website, and at some point the website has been received and the content is stored in the process in a member variable in this area. So we can just the process itself carries the result in this easy case, but you can use sockets, you can use pipes or named pipes or shared memory, whatever. Everything is possible, pointers. So there is no restriction in any way of what you can use as interprocess communication. That's your decision. Everything is possible still. So, yes, the application was not ended because this end of file bit must be checked first. If we are not at the end, then we have to check if we got a line that is useful for us. If not, then break. Just get another line, try to get another line. If we get a line that has some meaning, then push it into the list. If the list is too big, then reduce the list. And then we have to save the log here, of course. And otherwise, yes, that's it. So now it's and this area is quite easy for no matter where we are. We have states, and in every state we want to do something. Then we want to check, are we finished? Then return positive. This is the normal case. Exception cases are always in a block area, and this is a block area, for example. So every state is a block area, like a function is a block area, and in each block we have at the ich muss leider in den Lurk. Schreibe noch an meinen BA. Das ist die Abgabe. Aber viel Erfolg, ich gucke. Aha, yes. Viel Erfolg auch für dich. Bachelorarbeit. Viel Arbeit. Man sieht sich. So on the top we always have the exceptional cases. The exceptions, for example. And at the bottom we have the normal cases. The normal cases are like, we want to get the line, and in the normal case we add the line to the list and we reduce the list. This is the normal case. And one exception is that we are at the end, then we have to do some last stuff. And one exception is this. So at the top always the exceptions, and at the bottom we always have what we want to do in general. So let's try to execute this again. So we are saving, yes, saving to file, blah blah blah, and this is wrong because we see something strange. We see this saving to file, the date is correct, 23/07/27. That's correct and fine. Oh, stop. Yes, haha. Oh, that makes it easier. That's better. Oh, schau wie. Oh, wie dere. Oh, everything is working. Mwah. So cool. Coding is the best thing ever. So I want to have a different format. I want to have date and time. Date and time underscore log. Okay, so we have a different prefix, and the prefix is, so we don't have an index. Yes. and then if we don't have a prefix, then we just have a name of file, buffer. Oh, the buffer must be bigger now. Name base. Why is the name base 0? Yes, because maybe I have name base, arg name base, log. The default value should be log. So we have name base here. And okay, name file. So here we have list, get line, that's fine. Here we have, now I want to have the 2-hour clock time. Hour in 24 format, yes. Age, then I want the minute. And then I want the second. Perfect. And then underscore and then the base name. So this is the buffer. Prefix 2, 4, 6, 7, 9, 11. Yeah, that's absolutely enough. And the name file is this plus the base name, and the base name should be log. Index file, unused. That's a good warning. So as you can see, the base name is still 0. I don't know why. A log warning. Warning log base s get value c string. Poor. Is this possible? Is this working? Yes, the base is log. That's cool. That's cool. Then I arguments. Yes, because it's an argument. Yes, of course. Oi. Args. Yes, perfect. And then we have the same for the environment, the number of lines. Args. Perfect. How was your stream yesterday? Shout out to Keller Atelier. Two cool guys. Let's see if this is pronounced correctly. Yes. Oh, perfect. Keller Atelier is... how many were you yesterday? One or two or three? They are drawing cool pictures of different kinds, gaming pictures and comics and cool stuff. So now you see that this is perfect, and we add another .log to it. Perfect. And the base name, the default should be, let's call it FIFO. No, not FIFO. the extension should be log, but the base name should be, yes, we call it app. So yes, I think that's good enough, because now we save a lot of logic, because we have the seconds in it and the timestamp, and this means that we don't have to make any index stuff, and I want to see at which time this thing has been created. So we should be able to change this by making B and then TGS. Then we have a different name here, so that's cool too. And the number of lines, yes. So saving to file. So now it gets interesting, because now we want to open a file. Oh, file stream, I think. But I'm so lazy. I say C++ write to file. So how can I have a UF stream? Yes, an UF stream, of course. File log, whatever, and then an OF stream has we can say good forward to yes, not so we have the function open in the open file stream, in the output file stream, and come on, this thing should have no. Okay, then we do something else. Oh, stop. OF stream, we can make name file, and then we can check if not file log good, then return, then write an error. Yeah, let's make it return true. This makes more sense. Oh, come on, false. File log close. File log here we have the loop, list loop, and now we have a bool. This means here we have a bool too, bool, and bool means okay or not okay. So we have here bool okay, and then we say log safe. Okay is log safe, and if not okay, then return proc error log -1 and could not save log. I guess could not save log, yes. If not good, then oh, come on, stop. Return error. Error opening file, and then we should have a string error of error number, hopefully. Okay, let's make the loop. A list of strings. Iterator iter is equal to lines begin for iter not equal to m lines dot end plus iter do stuff, and then we say file log iter end line close. Has initial but incomplete type. What? I guess we should include an F stream stuff. We have a log and we have 2 lines. So now I want to decrease the size of the log with 1, and then we should, we have a new one, and this new one is sorted under the old one. This is the old one, and the new one should have only 1 line, but which one? It should have test2, hopefully. Nice. Nice. That's it. So cool, very cool. So now we want to register signal that is log save we should indicate in this function that it is the event. Okay, date time app log. So this is the default name, file name. But there are 2 cases in which a log file can be created. The first one, if the source has died or the user has requested a log. So we make a postfix that is called and or user. Okay. So and this means would we make bool triggered by user is equal to false. And then we say nope, name base, and we say if triggered by user, then name of the file plus equal string. Can we do this? User log else and let's deactivate for one moment. Yes, the file name seems to be cool. Okay. Usually we have a TGS end, application end log. Okay. But we should be able to in TGS to do we are registering the signal sig user 1 and this thing should do what? Do something. This is a static function of log catching a log save request. Bool, okay, and then we say okay is equal to log save true because it's triggered by user. If not okay, then we say warning log, and then we say that's all we can do. So, and this is a static function. Log save request. That's fine. Not declared. Cannot call member function without object. That doesn't make sense. That's the easiest way, so we'll do this. Bool false. Log save log require true. So this is and meanwhile here in this main function we say if log save requested, then do something. Very important. This line we should mark the request as finished. So we have registered on signal user 1. We execute the static function log save request, and we mark the flag log save requested initially false to true. If it's true, then and the process is in the main state, it's checking if the user has requested saving the log. Then we say yes, user triggered save the log. If not okay, then we make a warning. Otherwise we have fulfilled the request. This should be fine. Okay. Now we have the end log. Yes, that's perfect. And now we should now we need an application. We need an yes, we do. We make a test a test script. We make a test script. But this test script test.sh should. Yes, that's a good idea. This test script is bin sh, and then we say while true do done so open is fine, fstream tag get line reading. Okay. Bash increment counter. Come on, I just don't. You can use an arithmetic expansion in Bash. This is in Bash. Let's use Bash for the moment. Variable index is 0, and here we say tuck, and then we say sleep 1. Index is index plus 1. Hopefully this is working as well. Okay. Echo index index. Now we should have every second an index and a number. Index 0, 1, 2, 3, 4, 5, 6, 7. Yeah, that's cool. That's cool. And then we can press Ctrl C, and that's fine. Okay, that's our test script. That's good enough. And now we can say, instead of this strange printf, we say test, and this thing should store 3 lines, and it should run the application should run all the time. Why not? Index 0. Why? We should not have an end of file.